We've got 4 engaging panelists to discuss new forms of data for intelligent policing, all under strict instructions that we're not going to have a blizzard of PowerPoint slides in this part of the proceedings. So the format's fairly straightforward. My name's Paul Longley. I'm one of the co-investigators on the CPC grant. I work in the Department of Geography at University College London. We've got 4 panellists who will each open with a short position statement on some aspect that is relevant to new forms of data, big data analytics and intelligent policing. And so on my immediate right is Professor Alex Singleton, who's a Deputy Director of the something called the Consumer Data Research Centre at the University of Liverpool, who has extensive experience in using a range of consumer data sources to tell us more about what's going on in modern Britain at quite precise levels of spatial and temporal granularity. Next to him is Olga Feldman, who's technical director of Arcadis and joined the consultancy firm after a significant period working at Transport for London, where she also had responsibility for university liaison and is familiar with the kinds of collaborations that we see here in terms of the CPC project. Next to her is Trevor Adams, who's our good guy, our police buddy that Tao referred to in her opening remarks, because he's head of what is currently the data development team for strategy and insight at the Metropolitan Police. And so Trevor has been a stalwart and very much a friend of the CPC project, and I'm hoping will give an overview not only of how data are going to be the panacea for declining policing resources, hitting targets for increasing public confidence and hitting targets for decreasing in crime, but also the role of collaboration such as ours for being instrumental in that process. And then finally, at the end of the table, we're extremely pleased and honoured that Professor Mike Goodchild, Emeritus Professor from the University of California, Santa Barbara, has come over especially for this closing session. Mike will be known to anyone to whom the term geographic information science is familiar, because he's essentially the progenitor of almost anything that's of any consequence that the field has developed over the years. And Mike will say a few things moving beyond the operational domain, not only to look at international comparisons, spatial transferability, but also some temporal issues in terms of shifting the focus from routine policing activities to planning for disasters and emergency management. So I think first of all, Trevor, if you could just give us an overview of your thoughts and some of your reflections.
Right, good morning. Hampered by no PowerPoint, but there we go. We'll give this a whirl. I've got my PowerPoint in front of me. As far as the Met Police was concerned, we were approached by the university to support this project some years ago now. We've done previous collaborations in the past, but this was the first collaboration where we felt that there was a particular aim that the project had that we could support, because we saw it as being something that we actually wanted to get out of the project. We were conscious that with the recession biting across public sector, Like most police forces, the Met Police has had its budget cut considerably. Part of the, I suppose, the hidden consequences of reducing budgets has been a reduction in the number of police stations. Now, as the police stations have been closed, the officers from those stations have been moved into more central police stations, and we've got to a point now where there is approximately one police station per borough across London. So you've got 32 main police stations now. But the public purse is getting tighter. And the bottom line is that that is probably going to reduce even farther. It remains to be seen how tight the budget gets, but the likelihood is the one Met model, which is being referred to at the moment, is looking at how to reorganise the Met into even smaller units, but at the same time deliver the service that the public requires. Now, what we saw as a result of that was we were going to see police officers having to work out of bases and travel considerable distances. Now, seeing police cars rushing around on blue lights and two-tones has an impact on public's perception of policing. And what we wanted to know was, how does police activity start to impact on public perceptions? And some of you may recall back in the early 70s, there was a lot of concern about the police becoming detached from the public, in the sense that they were isolating themselves in vehicles, they were responding only to emergency calls, and they were not engaging with the public that they were meant to be policing. Roll on 20 years and you introduce the concept of safer neighbourhoods, and the idea there was to get police officers out of their vehicles, talking to the public and dealing with what the public were perceiving as their problems in their areas. When this project came along, we saw it as an ideal scenario where we could actually test some of those theories and look at the way in which we patrol in a level of detail that we simply don't have time to do internally. Talking to one of my colleagues earlier on, the value that we see academics applying to our data is the ability to be able to look at it perhaps differently from the way in which we've looked at it over the years. Many times people talk about the public sector as being data rich and information poor, and I think that is certainly true of many police forces. You know, we record incidents such as traffic accidents, calls to antisocial behaviour, and similarly we make records of crimes. But they're on two different IT systems, one for incident recording and one for crime reporting. And both of those systems I call reporting systems, because that's exactly what they are. We've taken a paper crime record and just computerised it. And very little thought was ever given to the information that you would then want to extract from those systems in order to be able to carry out proper analysis. Many of those systems, certainly in the Met, are years old. And whilst the concept of big data has been referred to, I'm not sure whether police services would ever regard their data as big data. I mean, the Met is probably the largest police force in England and Wales. We account for something like 20–25% of all crime and incidents recorded. But when you're talking about the numbers of records that the CPC project has been looking at, in terms of crime, it's around about the million level per year. It's going down, fortunately. Incidents, around about the £4 million records per year. But they've also been referring to the small in the newer data sets, mobile data terminal data. That's running at around about the 500 million rows per year. APLS, the personal radio transmissions, around about 250 million rows per year. So we're beginning to get to the level that we've previously not had to handle when we look at this data. Looking at the more recent additions to the data set that we've really not had time to look at in this project, things like the returns from the tablets. Some of our police officers are walking around with iPads now. I think they think it's very good. But obviously those prepare and present a lot of transactional log data. We haven't even started to look at that in any great depth. Body-worn video is another one where, as you can appreciate, there's a lot of publicity being given to it, but it is generating an enormous amount of data of which we've not had to handle before. All of these are giving us really big challenges for the future. Trying to get hold of what the bigger picture is has involved the researchers in this project getting an understanding of the data itself. As we said, we started off with incident data. That's a record of activity, really, from the police officer's point of view. But when you look at the way in which people call the police and what they call the police for, it's quite bizarre at times. You've probably read on or seen on the television some of the strange things that people call the police for. Simply, can you come and sort my husband out? He's arguing about which channel we want to watch on television. Hardly a 999 call, but that is exactly what's happening. When you look at the crime data, you have a similar sort of picture, that a lot of crimes get reported on the system. But when we were looking at the early data that was available to the project, they had to distill the crime data from the incident data. But you have instances where the public can now report crime online, so it doesn't touch the incident database. So the researchers have had to actually start to understand the relationship between the different data sets and how they can then research that information, extract the data from it to give them some meaningful information to work on. Location is the other one that we've fought with for some time. Location information on these systems was looked at as an afterthought. You're talking about systems that were built in a time when police officers knew their area intimately. I likened it to the fire service. All you had to do was get a fire engine into the street and then they looked for the people running around screaming, fire, fire, fire. And the police were very much the same. As far as actually being able to plot those information onto a map, it was an afterthought. And it relies on some quite archaic systems. Again, coming back to this particular project, when you're looking at location data, you have to either accept that you're going to look at the information that's on the source system, which has quite a number of issues, or you have to look at the system where you can clean that data up. And even that in itself can bring some inherent problems to the data. The amount of information that we have on the system that we can map now is pretty good. From the source system, it's actually only about 55% of the records are regarded as accurate. But we post-process that data, and we're pushing that up now to around about the 98% mark. We still have a lot of challenges. We have a project that's looking at building new IT systems for the police to use. I mentioned the iPads earlier on. One of our developers came and showed me their new iPad application for officers to enter location information. And she said, give me any location in London and we'll bring it up on the map. And I said, I'm a police officer. There's been a car crash outside this building. I've looked at the road sign. It says Lily Road, Southwest 6. There you go. There's your location. And she went, well, that's not good enough. I went, what do you mean it's not good enough? She said, well, I need a full postcode and a house number. Otherwise, it won't work. At which point, I suggested she went back to the drawing board, talk to some of the police officers that go into this data, and think about what information they have available to them. A lot of our information, unfortunately, is recorded in free text fields, and some of the things that we've been asking the university to consider is how to make best use of that data. If we sort of fast forward in terms of the things that we're being asked to do, the police are being asked to put more and more data into the public domain by way of open data sources. That has to comply with the Data Protection Acts. The Information Commissioner is quite clear on his guidance that he gives police forces about what data can be put into the public domain. My concern is primarily about the fact that most of the data that does get published into the public domain is not updated. We had an instance where one of our evening papers decided to do a piece on burglary. Again, it must have been a very slow crime day. But they did this piece on the most burgled street in London. And it turned out it was a tiny little back street in Heathrow. And of course, we then start panicking what's going on with this. And when we looked at it, what it is halfway down this street is the entrance into one of these long-term car parks for Heathrow Airport. And what had happened was some people had broken into the yard and they'd broken into all of these locked containers that keep all of these vehicles. So effectively what you had was 98 victims of crime, but all in one location. The original data which had been captured showed 98 crimes, but actually the Home Office counting rules, when it applied, shows it's just as one crime. So we went from the most burgled street in London to almost the least burgled street in London, just by a change of emphasis of counting rules. And that's something that the researchers have also had to get used to. If you think about the media at the moment, they talk about murder, knife crime, gun crime, and domestic violence. 4 crime types. But actually, of those 4 crimes, only one of them is a crime type that you can get off crime tables, which is murder. The others are all what they call flagged crimes, where it's quite a subjective application of a set of rules as to whether the flag should apply to that particular crime. And what we find is that when you look at it on one day, you'll find it's a domestic violence, the following day it's not. Go back 24 hours and it's a domestic violence again. So when you're looking at publishing data into the public domain, you are taking a snapshot in time, and you just have to bear that in mind when you're examining it. I think I'm probably close to my time limit. I'll just finish on a couple of lessons learnt. I think from the project's point of view, as has been mentioned already, it's useful to have somebody who has a good understanding involved in the project right from the start, and somebody that can come to the project meetings and talk to the team about what the data means. In the case of police data, a lot of it is regarded as restricted data, and the UCL have got a fabulous facility here that is being accredited to secure level, where they can hold our data without us having to depersonalise the data before providing it to them. That is a huge bonus, and it takes a lot of weight off my shoulders in the sense that it's not my problem once I've handed the data over. For the future, the biggest challenge that we've got now is taking all these data sets and merging them together. In the past, when we looked at intelligence in relation to data, it was something that the intelligence analysts did, not the performance analysts. But these days, what they're asking us to do more and more is to dig down inside the free text information and extract data that is not in the structured data itself. And that is becoming a huge task, and something that the academic world, we hope, is going to be able to help us with in the future. Thank you.
Very good. Thank you very much. So a change of application area, but very much an area of big data, TFL and movement data, I guess. Olga.
Thank you very much. So, as Paul said earlier, I used to work for Transport for London for 6 years, and I moved around a little bit while working for Transport for London. And my probably closest experience to working with big data was when I was a strategic manager analytics. And I was responsible for understanding how we can actually use that big data internally within TfL, as well as was responsible for relationships and building not only just sort of a research kind of relationships, but also working relationships in terms of applications with universities. TfL at that time sponsored a number of students from different universities, in particular MIT. I think the last time I was involved in that project, there were 9 MIT students which TfL was sponsoring. There was a number of students which were sponsored from Imperial College London and from UCL. And most of the areas of interest were obviously around big data. This is a modern topic. And TfL is interested in moving this area forward. And there were 3 sort of a particular concepts which TfL considered. First of all is big data per se. This broad area of big data is analysis of one or more large data sets. Owned by TfL or owned by someone else. But you don't want just to do the analysis of big data. You want to understand what is it, what kind of analysis, what is it that you're looking for, because otherwise you won't be able to succeed in your analysis. You need to know what is your aim. And a number of requests we were approached, TfL was approached by a number of universities when they said, I just want your big data. And we asked a question like, what for? We don't know. We just have a look at your big data and we'll figure out what kind of topic we want to study. And that's not how it works. You need to know what is it which you want to do with big data. And even after you know what you want to do, it's still not straightforward to actually do it. The other area, the other concept is open data. So TfL wants their data to be open to the public as much as possible, obviously subject to the privacy and other concerns, but open. First of all, TfL is a public body, so the organization is not for profit, and we want to invest every single pound which we are getting. I mean, we at TfL in this case, and obviously, when we're talking about open data, because TfL is sort of owned by public, we believe the data belong to the public. So this is sort of one concept. Another concept is just the question of time. So TfL receive lots of requests about a particular topic, and they want they want to save their own time. So they want to publish data, and to make the data openly available, so that actually they have to do less. And the third concept is data-driven decision-making innovations. And this is an important topic, and in particular topic which you as researchers would be interested in. And the idea is to understand how we can use that big data and how we can learn from it. And we started a few projects as research projects, for example, a so-called region destination interchange project, when an MIT student wanted to understand where people live in a bus. You can tap in, but you don't tap out. But as a result of that research topic, TfL has developed a whole tool which is called Region Destination Interchange, and now it's used by the organization in planning and in understanding what is the potential demand for future buses and how to expand this system. This is just one of many examples, and we want to integrate the data. So TfL wants to integrate the data, and in particular, there is this program of research which is called innovations, which is called the Surface Intelligent Transport System, and the idea is to link all the different data sets together, similar to what police is trying to do. And TfL is also trying to understand how within the organizations and key user data. One of the examples, as I mentioned before, is just to learn from the data and to understand how people travel, what kind of disruptions they have, and how we can help them how TfL can help people to minimize that disruption and to allow them to benefit from better accessibility, better reliability of their services. But actually, we also worked with police, and there was a number of areas where we helped. So in particular, a street enforcement team, they do work with TfL's data. They do analyze data, and TfL develop a so-called self-service tool within the organization, so they can do it now much more straightforwardly than before. And there are a few areas of research and of actually using big data. First of all is to understand pattern of crime, as before, and pattern of crime in more than one sense. So first of all, how people travel, and when they use bus 25 to 30 times per day, does it mean they're theft? Not necessarily. Maybe they just like buses. Maybe they're tourists. They just like travel. And there were a few examples when police were suspected that this person is likely to do something with crime because he or she is using bus so many times. And we found no, it's actually a lady. She's an old lady. She just have plenty of, I would say, free time perhaps. So, and there could be another area when actually there was a question before about revenue inspectors, and we actually do analyze our data. So TfL does analyze data, and there were at some point at least an area where through this analysis of big data analytics, we were trying to sort of place revenue inspectors in the right place. But we're actually working with police to understand how police officers are actually moving, and in particular, we used big data analytics to prevent police from to prevent police officers from committing a crime, in terms of that they were claiming they were in that location, therefore there is an overtime, so extra hours of work which they carried out. And when TfL actually checked Oyster cards, which were belonging to those people, that didn't look like that was the case. So it looked like they were actually at home at that time, or somewhere near home, because they've already tapped, sort of out near their home. So I think This area of research is enormous, and we do want universities, TfL does want to work with universities and to help. And as Paul said earlier, I've moved to consultancy, and within the consultancy business, we are working with the clients, so TfL would be one of our main clients. And Arkadis in particular have worked with big data analytics, have worked with big data per se, a number of areas in terms of transport, first of all, to understand origin and destination. So we use mobile phone data and we use GPS data to understand how people travel. But we also worked with police, particularly in France and in Netherlands, and we use the GPS data and we use other data sources, camera data, etc., to help France and Netherlands to organize Tour de France so a few years ago, and similar with very large events. So I think big data analytics is probably the future, and we already spotted that. So
very good.
Thanks.
Very much indeed. The next is Alex Singleton from the University of Liverpool.
Thanks, Paul.
Is it working, by the way, or am I just growling into it? Okay, thank you.
Okay. Thanks, Paul. My sort of allotted topic was to talk about opportunities for use of consumer data, and particularly big consumer data, in applications related to policing. When I started thinking through this, I've ended up framing this around this idea of human dynamics, which are ostensibly how people use space within urban areas over a variety of different sort of temporal resolutions. Big data has been mentioned in a number of the talks and also this morning, relates to a particular defined class of new form of data, which has a series of characteristics which mean it's more difficult to manage than perhaps traditional data. Big data tends to be much larger in size, which means that traditional mechanisms for managing data, such as databases, aren't necessarily applicable, and there are specialist softwares developed in order to sort of manage the data, but also perform analysis on it. The data often comes in a variety of different forms, so it won't necessarily be structured, it could be unstructured, it could be text data. The data is often more uncertain, or arguably more uncertain than more traditional forms of data. It can come from a variety of sources, and that can lead to all sorts of different analytical problems related to bias and quality control. Big data is also often streamed. So in terms of traditional data, so a census, we may well have a data set which was collated a number of years ago. It may have been cleaned, it might have been structured for us and presented to us through some sort of interface which we can use in our own analysis. Whereas with big data, that data might be being generated in a continuous stream all of the time. So it could be streamed satellite data, for example. And that also obviously relates to the volume as well, because there's more data over time, larger volumes. And particularly related to consumer data, and something that Paul's also the principal investigator of something called the Consumer Data Research Centre. One of the challenges that we have when we're using consumer data, and this is a sort of a peculiarity, much like the police data, is highly sensitive, both to the data owners, but also the general public, who've essentially contributed to the data through their interactions with retailers. So there's access controls, which may mean accessing consumer data can be a challenge. And this is also a challenge related to some of the other facets of it, being big data, particularly the streaming analysis, the streaming elements, which typically would only be available within retailers themselves. So I suppose what I've got are sort of a couple of slides here, and again, we're not showing slides, on academics rarely listen to instructions, but essentially about different types of human dynamics, and that relates both to sort of opportunities and challenges. So in going through these are the types of things I think you could do with consumer data, and ostensibly consumer data that we hold within the CDRC, which is my sales pitch, related to policing. In In terms of slow dynamics, these are the dynamics which happen over longer periods of time. They're more akin to censuses, but they are probably shorter time windows. So you may look at things annually on a rolling basis. The things that you can do is you can pull data on housing. So you can look at issues of, sort of housing churn, which relates to sort of the conditions that people live in and the permanence of people within areas. Potentially, you could use these data to detect things like market failure, which has obviously got sort of knock-on implications. Slightly differently, high streets themselves, I think, can be thought of as sort of a long-term sensor of the health of the economy, and we've done quite a lot of work on looking at retail resilience. You can look at vacancy rates, which are sort of monitored over time, and obviously the more vacant units you've got within a locality, that has obviously implications for sort of policing, but also it gives an indication of whether people are actually spending money within those locations. Faster human dynamics. So these are things that we can sort of monitor in near real time or very close. We can look at transaction densities within retailers on the high street. So that will give us an idea of how many people are within particular localities over time. It might be possible to look at the basket level data for particular retailers and whether that tells us something about the characteristics of the people who are within those localities as well. So it moves away from just pure people within locations. We can build in models which look at transport ingress and egress. So we can actually see how many people, for example, are exiting tube stations or using bus facilities. There are challenges about where those people go once they've left those particular facilities. So they might be recorded as leaving the tube, but where they're likely to go next. We can connect those kind of data up with other behavioural models, as agent-based modelling. And there's a challenge methodologically about how you can bring those real-time streams into modelled outcome sort of computer simulations, which then can lead into some kind of response. Other types of data include things like social media. There are challenges about how we actually extract content from them. There was some techniques were mentioned this morning, but also those kinds of data, as with many of these types of consumer data, have a lot of bias. Some of that is known and some of it is unknown. And there's a lot of methodological work needed to sort of improve our understanding of what those biases are and, as best possible, account for them. Something that we've recently invested in are sensor technology. So part of the CDRC activities, we're going to be positioning sensors across UK high streets. These work with mobile phones. When you pass a retail store with one of these sensors in the window, it records that location. Those kind of data are going to be available in sort of the next year or so. And again, they give a barometer of sort of people's use of space within the retail setting. So the final thing really is, I think, for me in the research that I'm interested in is geodemographics, so how places can be understood through the attributes, through their attributes. And there was some geodemographic examples mentioned earlier on too. I think with these new forms of data, which enable more sort of dynamic processing of areas, we can start to think of areas over sort of more finer-grained temporal resolutions. So essentially, places can be characterized by the bundles of activities which happen within them over time and not just necessarily at a sort of a 10-yearly census interval. And I think there's some real opportunities for extending geodemographic methods and their applications, obviously, for policing. And I think the final point I'd like to make is with a lot of these consumer data, we go beyond being able to say there are people moving through a zone and tracking people. The space-time prison example would be was illustrated this morning, to actually attaching attributes to how those people who are moving through zones. And those people, as they move through different zones within urban areas, in fact, characterize those places. And it's that which I think we can capture through these data.
Very good. Thank you very much, Alex. Finally, Mike.
I think we live in a very interesting period. We're seeing a massive expansion in the availability of data. We talk about big data. And it's always, I think, the volume of data, which is the most engaging characteristic of big data. We talk these days about the exaflood. Exa is 10 to the 18th Probably before the end of this year, we will be talking about the Zeta flood, 10 to the 21st. And it won't be very long before we're talking about the Iota flood, which is 10 to the 24th. And if you're really interested in becoming famous, 10 to the 27th is still up for grabs, if you can think of a suitable prefix. As I say, volume is the most conspicuous, but if one follows the literature talking about the 3 V's, then variety and velocity are also very challenging aspects of big data. We are seeing data now in near real time, the velocity aspect from sensors, a variety of sources, producing the variety aspect, and all of this within a context of confidentiality and also the general question of trust. How can you trust a lot of this stuff? Much of the data is geospatial. It's tagged with GPS coordinates or place names, which makes people like us very happy. It provides profiles of places hour by hour as places switch from, let's say, residential dormitory use to workplace use to restaurants, bars, and nightclubs. A constantly varying socio-demographic mix, varying through the 24 hours of the day, varying through the 7 days of the week, and constantly varying security concerns and crime concerns. In this sense, the city is now truly dynamic, especially the inner city. And yet, of course, much of the tradition of social science over the past decades has been to see the city as static. And the city is also three-dimensional, but much of our prior work has essentially been two-dimensional. Within this context, then, and I think it's a very challenging and exciting context, there are many long-standing concerns. And as Paul suggested in the introduction, I want to draw on some of the experience I've had with questions of data use in response to emergencies, because I think we can learn lessons from the emergency situation, which are nevertheless relevant to the context of crime. Emergencies require widespread data sharing. And yet, confidentiality concerns, privacy protection often argue against widespread sharing. Moreover, at a more fundamental level, information is power. And information is often, attempts are made to monetize information, which again works against sharing. Information, thus, is often closely held. And yet, in the context of a major disaster and a major event, such as Hurricane Katrina or 9/11 or the Oklahoma City bombing of the 1990s, there are many overlapping jurisdictions and agencies in the private sector. There is a sudden shift from holding information closely to needing to share it rapidly and widely. And that creates a very challenging situation. This is not a shift that can occur instantaneously. And after the event, think of the problems of reestablishing close holding, in other words, clawing the information back into the traditional, well, closely held context. Moreover, it's impossible to know where and when such events will occur. It's impossible, therefore, to assemble data in advance, especially given privacy concerns. So out of this comes a rule of thumb. I think it's very interesting that in all of those 3 instances, Katrina, 9/11, and the Oklahoma City bombing, it was 72 hours after the event before the relevant data could be assembled from the diverse agencies from the private sector into a useful and productive package. It was 72 hours before maps could be produced of the 9/11 site or of New Orleans after Hurricane Katrina. And moreover, these concerns are going to get worse because the sources will continue to diversify, the volume of data will continue to increase. National mapping data is now augmented by Twitter, other social media, and by rapidly increasing networks of sensors. In this kind of context, if you want to approach it with bilateral sharing agreements, let's put sharing agreements in place before the disaster happens, then within organizations, agencies, private sector companies, there would need to be N-squared agreements. And this becomes rapidly unmanageable. So if you have, for example, the state of New York after 9/11 was contemplating 700 bilateral sharing agreements. And simply putting those in place is an enormously challenging problem. And then the last problem, go on the web and try to find the data or the software or the data models that were constructed after Katrina or after 9/11 or after the Oklahoma City bombing. They've disappeared. Because the fundamental fact is that we have no technology for archiving and long-term preservation of any of this stuff. And that's a very deep concern. So what to do? Because that's I think, the existing situation. What to do? We will develop, and we are developing, better technology for data integration. And that problem is becoming much less severe than it has been. We are finding better specifications, and with better specifications, such as the ones developed by the Open Geospatial Consortium, agencies, if they can agree to be interoperable, will now find it easy to share information. We are getting better understanding of quality and provenance issues and metadata. We are achieving faster processing. We're using high-performance computing now and massive storage. The Cyber GIS project in the US is demonstrating many of the benefits of this. We are getting better user interfaces, better methods of visualizing. All of this will help. But many of these issues stem from fundamentals of human behavior and culture. And as such, are they truly intractable? And I think there is only perhaps one cause for optimism in that context. And that is that this new generation, I believe, is truly different and much more likely to be supportive of openness and transparency and sharing. So that perhaps culture and human behavior are not the absolutes we might have suspected them of being. So I want to make a couple of comments specifically about this research. First, one of the big achievements we've heard this morning is the transition from a two-dimensional grid-based approach to a street network, and to the scale of the individual officer and to the scale of the individual crime. And that's a tremendous advance on a lot of what's happened in the past. At the same time, policing occurs in a three-dimensional city. It occurs within structures. And the network, the street network, is still a very high level of abstraction. So given current trends in technology, where the technology is heading, and particularly data acquisition technology, I think we can see what the next generation might look like. The next generation would be much more concerned with off-network access. The street would be a mix of pavements and crossings, the alleys, the staircases, the lobbies, the parks, the parking lots, the open space. All of that off-network access would become part of the database. Rather than having to distribute things on a linear network, this is a much richer sense of geography. It's also a finer scale, of course. The technology, as I say, already exists for that. We can see that this will occur soon as part of the big data paradigm shift. And then just one last point. And in IT-based research, one very often hears the phrase, build it and they will come. Right? Build it and they will come essentially captures the notion that the research community knows what is good for the user community, does its research, develops something, and then puts it out for the users to adopt. Right? And I think there's a very definite element here of something different. Let me suggest first a comparison, an analog. Compare this to the cab driver. Right? The cab driver perhaps has a sat-nav system, most these days do, but does not rely on it entirely because the cab driver has knowledge that the sat-nav system lacks. So an ideal sat-nav should be capable of capturing that knowledge and using it to advise on routes. Right? So translate that to this context here. Does the IT capture all of the knowledge of the officer? What does the officer know that is useful to policing, which the IT captured in this system, for example, of a street network, doesn't know? And what of that knowledge could be usefully captured, shared, analyzed, and monitored by the IT? And I've already suggested one obvious answer, which is the 3D structures, the off-network access. These are things that are known typically to the officer, and yet in a street network-based IT are not available through the IT. So let me suggest that that's an important perspective. It's seeing the research as driven by the specific needs of the officer, which is rather different from the polar extreme, the polar opposite, which is build it and they will come. So thank you for your attention.
Very good. Thank you very much indeed. Before I throw it open to questions, as Mike was speaking, I was thinking myself about how we actually effect transfer of data and the ideas that underpin the creation and maintenance of large and complex databases between academics and between data creators. And perhaps to go back to the other three panelists before we sort of throw it over to general questioning. I'm aware the title of this session is New Forms of Data. It's not new forms of information. And although we use the terms data and information almost interchangeably, closer inspection really reveals the information implies some sort of selectivity, some preparation for purpose, and many big data are very raw in the level, if any, of preparation for any purpose that they've been made. And you said this, that Olga, when you were saying when people come to you and they want to do something with data with no immediate focus. And so, in some ways, we're sort of at, we're at a point where traditionally we think of data being turned into information, it being built into evidence, evidence then being fermented into some kind of knowledge. But I think each of the other discussions as well really sort of alluded in differing ways to the tacit knowledge that you need to understand big data. And I was just wondering sort of whether you have any reflections whether you have any reflections on the way that that tacit knowledge moves between the academic and the transport, the policing, the consumer data sectors.
Yeah, I have a comment about big data analytics within TfL. So, as I mentioned before, this is a huge topic within TfL, and relatively recently, TfL has developed so-called data warehouse, CSA. And the idea is to collect all the Oyster card, contactless, Apple Pay, etc., all that data, and to store individual transactions, individual data for a much longer time. It used to be just 8 weeks, after which data was aggregated, and now the idea is to store it for 3-5 years, if possible, or longer. And there was a question about potential work with researchers. Immediately, 2 questions. So first of all, you have to anonymize data. So someone has to do it. So someone within TfL who, in addition to do this, needs to carry out other activities. And for example, support TfL on a day-to-day basis by analyzing, disruptions or whatever, all the other sort of information, or for example, issuing refunds to the customers, etc. In addition, they have to prepare this data set. So what TfL ended up with is providing very limited number of data sets to all the universities. But as soon as you do that, then everyone is sort of doing research with exactly the same data set. Yeah? So how much you can learn, how many people are supposed to use the same data set for their research, which is very often in the same area, for example, understanding disruptions. So if you use just 8 weeks of data, 20 researchers, so, every single researcher would just bring a small margin to what everyone else, done. So you have to move into a different era. And within that sort of data warehousing, the idea was to create an access for researchers. So I'm not sure where exactly TfL is right now, but the idea was to build a so-called research area, so that researchers can, after signing non-disclosure agreement, etc., can actually prepare in a way those data sets themselves, so that, first of all, they would prepare something specific for them. Maybe they're interested in disruptions, maybe they're interested in actually normal days, maybe they're interested in particular events. So if you do it in advance, you need to guess what is it which researcher would be interested in. But if you tailor it to your research, then obviously you would get more benefits from analyzing the data. But there is this immediate question about privacy and about actually spending time on creating that research area. And then what is the procedure for getting access? Who is eligible, not eligible? What sort of information you have to sign? And in addition, data fusion, so TfL is very much concerned about, fusing their data, which looks anonymized, and sort of unlikely to be sort of understood on their own. But when they fuse with other data sources, then there is a potential that a particular customer would be identified. And this is a huge, huge, huge area of concern for such organizations as TfL. Okay,
thank you. And perhaps I could just finger Trevor's collar. I mean, I know, Tao was very keen in the early stages of the CPC grant that the postdocs went out on police patrols, and every one of the PDRAs spent at least one night, sort of driving around the streets of Camden, as I recall, at one stage in the research. I mean, now it's all over, Trevor. What are your reflections? Would you say you've succeeded in transferring your tacit knowledge of strategy and insight in terms of policing to the academic sector, or are we still hopeless?
I think the answer to that is somewhere in the middle. I mean, I've been in the Met Police now for 42 years, and I did 30 years as a police officer, and then just sort of retired on a Sunday and started work again on a Monday. So I've seen an enormous amount of changes, and I'm very conscious when I talk to the researchers that some of the information that I might impart is often out of date. Although, cast my mind back many years, I remember spending some time in a specialist department and then being told that I need to get back out on the streets to learn how things were going on in the real world. Having got my feet back under the charge room table in a quite busy police station, nothing had changed in 5 years at all. And I suspect the way we police hasn't changed that much. Some of the technology that we use has certainly changed, and that's brought about some opportunities, which I think we've yet to really grasp. Something that Mike and Alex said earlier on was about the use of sensor technology. When we were looking at things like street populations, it's very difficult to get hold of information that tells you what your street population is. Most of the information that we have available to us is based around residential population. And yet we know that, as was said earlier on, that the nature of an area can really be transformed just as you go through the 24-hour period of time. It was sort of quite remarkable. I was in with the Deputy Chief Constable of British Transport Police yesterday. We were talking about stop search, nothing about demographics. But he was saying at the end of his tour of duty on the Sunday, he decided to ride his pedal cycle down the canal path in Camden. And he just couldn't believe the cultures and what was going on the canal path in terms of the way in which it was almost a totally different community to the community that he experienced at street level walking through Camden. And we don't really have that level of information yet, and yet it's crucial, I think, in terms of understanding patterns of crime.
Can I ask for any general questions arising? Got one there? Thank you.
Like this. Okay. This is probably more for Trevor, give or take the microphone. So we've been talking a lot about all the big data that's out there, and we've been concentrating on that. Are there areas that you think we should be thinking of where there's a paucity of data, but would be really important to actually try and address those issues?
Difficult question. I mean, referring to what I said earlier on, the paucity of data from my point of view is around the different ways in which areas change during a 24-hour period. And as far as we're concerned, things like the APLS data, although it is streets away from the sort of information that we used to have, where activity was recorded at the end of a shift on a piece of paper, we can now actually track officers' behaviour and see where they've been. The technology itself is quite crude, to put it mildly. It's not as good as your mobile phone tracking. The refresh frequency was spoke about earlier on was originally 15 minutes. It's down to 3 minutes. But in reality, we need to get that down to probably sub-minute, down to second level. But the difficulty that we have is that the networks that carry this information are at a level of capacity which tends to suggest that we can't push that any farther, not with the current technology. So we're going to have to change the technology, which of course is going to cost money, and that's the one thing we don't have at the moment.
I think at a different level of granularity, perhaps to ask Alex a question. I know when we were drafting the CPC final report, one of the things that I put in was based on some of the work that Chris Gale did on the project when he worked before he moved to the University of Southampton. The need for classifications of neighbourhoods to be open, transparent, and reproducible. And so we recommended, unsurprisingly, a classification that Alex and I had sort of implemented called the London Output Area Classification that I think Richard Fairchild from GLA is in the audience, and there's a bit of work that we did with the GLA. Trevor didn't like that because it was all about 2011 data. I wonder, Alex, if you've got any sort of reflections yourself on the difference between something that's proprietary, black box, up to date versus something that's open, transparent, reproducible, and out of date.
I feel you probably predict what my response will be on this. Out of date is probably the wrong term. And it's the extent to which you agree or disagree with whether areas themselves change that rapidly over time. So we are talking about, in local terms, in terms of a nighttime geography. So it's where we sleep. So it's based on census data. And obviously there are changes in those locations during the day. With the data that I was talking about in sort of my 5 minutes, there are opportunities to provide updates to classifications between census time periods, and indeed we've actually had a project to do specifically that, to look at the intercensal period. But it's actually what transpired is it's actually very difficult, and it's very difficult to combine these non-traditional sources of data with census data. The advantage of the methods that we would promote, perhaps with sort of less temporal granularity, are that the methods themselves are completely transparent. The data are, at this current stage, available just to download from the internet. They're totally free of access. It may be that we have to move towards models which are more akin to what the commercial sector do, however, maintaining the transparency and openness of the specifications. But given the data which we need to actually improve the temporal resolution of classifications, it may be that there has to be some access protocols which mean that they have to sit behind a firewall. So the sort of secure facilities that we've built, both for the CPC grant and the Consumer Data Research Centre. I still feel comfortable that that is an open and transparent solution. The methodology is completely known, and if you did want to come and test those classifications and our assumptions on how we've built the cluster models, you would still be able to do that. It's just you might have to do it in a sort of dark basement without any light.
Okay, ladies and gents, I think we're just coming up. We're just coming up on time. At a Tao Cheng conference, panels always mean prizes. So I have a some small gifts. Professor Goodchild likes Yorkshire tea, so and Nairn's oatcakes, so that's what he's got. Here with monotonous regularity and akin to your crackerjack pencils. That dates me. Space-time mugs and goodie bags. So I'd like everyone to join me and thank our panellists for a very stimulating session. And lunch is now served. Thank you.